Welcome back to Dave Does Math from Home. This is part 2 of our video series on linear equations from section 1.2a. We talked about the basics, the standard technique for solving linear equations in the first part of this video, but in this part we're going to talk about some weird, bizarre corner cases that can happen sometimes and what to do about those. So this is one of those weird, bizarre corner cases, and I'm going to start solving it to figure out why it's a niche, bizarre corner case. So first we distribute things. There's no fractions to worry about, so I don't have to clear the fractions. So first we'll distribute things. I will get 6x plus 14 equals 4x minus 4 plus 2x. I will combine like terms to get 6x plus 14 equals 6x minus 4. And now I can move everything to one side. I'll subtract 6x from this side, and then also this side, and I'll subtract 14 from both sides as well. And these things all cancel, and that cancels, and it leaves me with 0 equals negative 18. Which is a problem for us because 0 doesn't equal negative 18. This is not true. This is false. That's just not a thing that happens in math. You can't make 0 equal negative 18. The x's are gone. So, in these situations, we say that there is no solution. There is no x value that will make this equation equal this equation, because when you simplify them, this is 6x plus 14 and this is 6x minus 4. Whatever 6x is, when you add 14 to it or subtract 4 from it, you're going to get different numbers. You can't make those things match. So there's no x value that makes this true. This is no solution. That's what it means when you get a statement here that is just fundamentally false and can't be true. Sometimes the opposite happens. So you might get something like 7 times x minus 1 plus 3x equals 4 times x plus 2 plus 6x minus 15. If you have an equation like this, once again, we should start by clearing fractions, but there's no fractions to clear, so we can skip that. We can move to the part where we distribute. So 7x minus 7 plus 3x equals 4x plus 8 plus 6x minus 15. And if we combine like terms, we'll get 10x minus 7 equals 10x minus 7. Some of you might already see where this is going. If you try to keep going, you'll get negative 10x. You can subtract that from both sides. And then you have negative 7 equals negative 7. Or you could add 7 to both sides if you like as well. You get 0 equals 0. This is a very different statement from 0 equals negative 18. 0 equals negative 18 is a problem for us because it's not true. 0 and negative 18 are different numbers. If we get a statement like negative 7 equals negative 7, or 0 equals 0, this is always true. It doesn't matter what x is. 0 will always be 0. In this case, the solution is x equals all real numbers. Or in interval notation, not that, negative infinity to infinity. any number you pick, any number at all you pick for x, will make this equation true. You'll always get whatever this evaluates into. Like if you pick 20 for x, this is 200 minus 7, so this will be 193 over here. This will also be 193 if you pick x equals 20. So it doesn't matter what x is, this is always true. So the solution is everything. That's it. That's the end of the weird niche cases. Usually when you do these problems, you'll get a single value for x equals some number. Sometimes you get statements that are false, and that means there's no solution. Sometimes you get statements that are true, and that means all solutions. That's it. That's solving linear equations.